Thank you for joining us here today after what was hopefully a beautiful long weekend for you and then a full day of teaching. So I can imagine most of you are pretty exhausted. So we really appreciate you showing up today for our just-in-time math PD session. So just a reminder, if you weren't here last time, we will be doing these just-in-time sessions for every topic in the long range plans except for the next topic, but I will address that near the end of this session. So just about a week or 2 weeks before you will be starting your next topic, we will make sure that we have just a quick after school session to kind of give you the lowdown on what's important about the topic that's coming up. Okay. So a quick reminder, this is our learning support staff that are supporting math this year. And today you have with you myself, I'm Rhonda Hewer, and also Michelle Lang is helping us as well today. She will be addressing anything in the chat. So if you have any questions, please put them in there and she will make sure that they get addressed. And if you're a distance learning teacher, you might be looking at Hebron going, what's he doing over there in junior? He is actually doing junior just-in-time PD, but he does support the intermediate distance learning program as well. All right, today's menu. So in our new curriculum, they are using some fancy schmancy algebra terminology. So we thought we would take a few minutes to debrief some of those terms. Then we are going to move into what concrete representations, visual representations, and symbolic representations we use to develop algebraic reasoning. And then, as always, there was a Slido. There will always be a Slido, which is a question format. If you have any questions for us, you can post them there, or you can go and check what questions are there and upvote them so we know what are the most popular questions, and we will be addressing them in these sessions. Okay, so this is why I was suggesting you bring an extra device today. So if you have a phone, this works really, really well on a phone. If you have like another laptop or Chromebook, it will work as well there too. This is going to be our terminology part. We're going to play a little Kahoot game. So if you can go to kahoot.it on your phone or the extra device and then enter this code. But what will have to happen is you're going to have to come back and watch my screen to see what the questions are. And you will be answering the questions by picking the right color on your second device. So I'm going to give you some time to get that set up, but not much time. And Michelle, I'm just going to go over to the actual Kahoot screen now. I'm not sure. Oh, it's still there. Okay, no problem. Oh, we have Gauss joining us today. Isn't that an honor? Haven't talked to him in eons, perhaps a century. How many people roughly should we be waiting for, Michelle?
About 13, I think.
Okay, so we got about 4 more that are joining, and then we'll get her going. And I think, Michelle, that game pin stays on the screen as we're playing it.
Yes.
So you'll just, if anybody else joins us, you'll just have to let them know that. Oh, Algebra. That's awesome. Welcome, Al. Such witty people here today. I believe that is, yeah, it's a Fibonacci sequence right there. I think they're testing us, Michelle.
I think so.
Now, when I start, it might play music, so I'm gonna mute that music because it's super annoying. I think we're gonna start.
Okay.
Oh, because you know what? The other 2 people might be us, is it?
No, because there are 16 that are currently in the meet.
Oh, okay.
So you are 2 of them, and I'm 1 of them.
Okay. And we are pretty good at math, so you did that well. Okay, here we go. Welcome to the JIT. Oh, yeah, it's whatever. I'm not going to read it. The difference between an equation and an expression is, so you are going to click on the color or the shape if you're more spatial than color, of which one of those you think the answer is. The difference between an equation and an expression. Oh, come on. Who thought the llamas are funny? You're out. We're going to find out what school you're at, and we're going to have a conversation with your admin. Absolutely correct. And this is important. So when you're talking to students about this, make sure you're using the right terminology. If it's just an expression, it's not including that equal sign, you need to make sure you're calling it an expression. If it has that equal sign in it, then you can call it an equation. All right. How many terms are in this expression? And just to note that at the end, that's 4 multiplied by 2, not the variable x. That's 4 multiplied by 2. So how many terms are in that expression? Ooh, we're all over the map there. So the answer is 4, and I'm glad that some of you chose 5. I put that in there as a trickster. A term is separated by an addition or subtraction sign only. So when you look at the curriculum expectation, it might say multiple terms, it might say 1 term. This is what your clue is, that you can have, it can have a variable, it may not have a variable. It can either have a variable or not a variable, but there will be an addition sign between them. So 2z, 3zy, z squared, and then 4 times 2 is actually a term. 4 times 2 equals 8, that's a term. Okay, what is the coefficient in this expression? 4x squared plus 1. Which one is the coefficient? Correct. 4 is the coefficient. So the coefficient is also known as the multiplier. It's also known as the rate of change, and it is the number that is connected to a variable through multiplication. It could be a fraction, it could be an integer. In this case, it's 4. So a coefficient isn't actually in the curriculum expectations, but it will come up as you are talking to students about algebra. So the coefficient in this one is 4. Look at CE is on fire. Wonder if CE put that there or if that comes because of Kahoot.
It comes because of Kahoot.
Okay. An example of a monomial is? Okay, phew. Nobody chose red or green. A monomial is 1 term. So it is an expression that contains 1 term only. So remember, we talked about a term is separated by a plus or minus. So you can think of that as mono. Mono usually means 1. Monomial means 1 term in the expression. And you will see that in the curriculum expectations. Is that you, Michelle Lang?
It is.
What are you doing?
I'm playing.
In all fairness, Michelle Lang has not seen the Kahoot before this very moment. She was not exposed to it. Which of the following expressions does not have a degree of 1? Great. So again, you're going to see this in the curriculum expectations. So when we are talking about the degree of an expression or an equation, if it only has 1 variable, then we are talking about the largest exponent in the expression connected to that variable. So all of the other ones only have an exponent of 1. Even this green, I was hoping I would get somebody with the green because it's s plus t. Because that s and t is not together in the same term, that expression only has a degree of 1 because the highest exponent for each variable is 1. If we have a situation like this where we have more than 1 variable in the expression, then you add up the exponents in a term, and that's your highest. So in this case, 2xy, x has exponent 1, y has exponent 1, but together that term has a degree of 2 because they belong to the same term and we are adding up the exponents. Hopefully that makes sense for you. In grade 7 and 8, we are only looking at degrees of 1, which is actually linear relationships. A degree of 2 would be what we call a quadratic relationship. Degree of 1 is linear. Good. Someone kicked Michelle out of first place there. An example of a binomial. So see if you can piece that together now that you know what a monomial is. Excellent. So a binomial is going to have 2 terms. A monomial has 1 term, binomial has 2 terms, and remember, terms are separated by addition or subtraction signs. So in the case of blue, the degree does not matter. So in the case of the blue expression that we see here, we have 16t squared, that's 1 term, and 2 times 8t, that's the 2nd term. So we have 2 terms. Green has a degree of 2, but it is a monomial because it's only 1 term. But the degree of 2 because the exponent is 2. Good for Gauss. He's a little rusty. He's been out of math for a while. All of the following numbers are considered integers, true or false? Correct. That is false. So the decimals and the fractions are not considered integers, nor is the 0. Those would be considered rationals, not integers. Integers are basically, you can think of them as whole numbers, positive or negative whole numbers. SJ, I want to say it's like St. Jacobs. Okay, so rational numbers are what? Rational numbers what? Good. Rational numbers are any number that can be represented as a simple fraction, positive or negative. And we're bringing that up because in grade 8, you are going to see rationals throughout the curriculum, not just in algebra, but throughout. And so thinking about what might not be a rational number are irrational numbers. So pi is an irrational number. The square root of 2 is an irrational number because it cannot be written as a simple fraction. 0 is a rational number because it can be written as a simple fraction. If 0 is in the numerator, then anything in the, doesn't matter what's in the denominator, the fraction is 0. So it is considered a rational number. Okay. And that is it. So let's check out our podium here. Oh, I forgot that that was a name. And our winner, Gauss, as it should be. So Gauss, you get the bragging rights for something nobody else is ever going to care about. But you can say you won the Kahoot at the junior intermediate. I mean, at the just-in-time intermediate math session for algebra. Now, coming on back to the Pear Deck, that's it for Kahoot for today. There's a couple things I want to say. If that deflated you a little bit because you're like, all this terminology, I didn't know any of it, I maybe shouldn't be teaching math. I don't want you to feel like that. They are throwing some fancy terms around now. But if you go to the ministry's curriculum document, any of those words that we've just gone through would have like a dashed line under it. And you can just click on that dashed line and it will give you a definition right at the bottom of the page. So if you're kind of confused and you're forgetting what a monomial, a binomial, any of those things were, just always go to the ministry's curriculum document. And maybe, Michelle, do you mind just putting a link in the chat to that so people have that handy? It's probably not a bad thing to bookmark that.
to
The other
the,
thing I wanted to say is we're going to be using quite a bit of technology today, and we're doing that because we do have some distance learning teachers with us as well. There is a slight chance that we might end up back in a distance learning situation, so we're trying to model for you, and you could do this in your classroom always as well, in a face-to-face classroom, but we're trying to model for you a variety of different ways that you can integrate technology into the learning of math. We are throwing a bunch at you today. We are not recommending you would do all of these things with your students in one lesson. We're just kind of showing you what's out there. So you might do a Kahoot, you might do a Pear Deck another day. We're going to be going into Desmos. That might be another day. We're not expecting you to be doing all of this in the same lesson. Okay. So here are the expectations that we are focusing on right now in this algebra topic. If you go onto the grade 7 and grade 8 math long range plans, you're going to see that there was inequalities and it's now been crossed out. It makes sense for us to do inequalities as part of this topic. However, the rest of the province hasn't caught up yet. So a lot of math resource providers such as MathUp, or the ministry is coming out with some lessons, OME is coming out with some lessons, any other lesson providers don't quite have inequality lessons prepared yet. So we thought it would be better, more beneficial for us, since this is the first time we're teaching inequalities, to move that to the patterning part in term 2, when more lessons are going to be available for you to use with your students. Now, we've given 15 days for this topic, and that was when we were thinking inequalities as part of it. So you might not need the whole 15 days, but that's okay, because it kind of gives you a buffer in another area that you might need, that those extra 5 days are going to come in handy. You might need the whole 15 days. It's going to be totally dependent on your class. But looking at this slide here, you can now see some of those words that we were just playing with, and you can also see how it progresses from grade 7 into grade 8. So you can see the difference there. So in our first expectation in grade 7, we're using monomials, which is one term with a degree of 1, so it's linear, and you're only using whole numbers. But in grade 8, we're also going to be adding binomials, and we're going to be involving integers. So I'm not going to go through each of them there, but you can kind of see from this slide and refer back to the slide to see what the difference is between grade 7 and grade 8. Are we cool for questions so far, Michelle?
yes, we are.
Okay, cool. Okay, your role as a math teacher is, some people get confused when we talk about concrete to symbolic or visual to symbolic, and they think, oh, I expose all the students to all of these methods, and then the students choose which one works for them. Yes, to a degree. We eventually want students leaving grade 7 and 8 living in the symbolic world. But we're using concrete and visual representations to develop that conceptual understanding, so that it's not just a bunch of procedures and rules thrown at them that they're going to confuse later when they're in secondary, or that they don't have the anchor charts, or we're not in this topic right now, because we're going to be revisiting expressions and equations throughout this entire year. So we are spending 10 to 15 days right now developing their understanding of what's important in algebra, so that they're able to apply it in any other situation that they come on. So your goal and role and job as a math teacher is to be making connections between the concrete and the visual and the symbolic. And that's why you see double arrows in this diagram. A student might be at a place where they are representing things symbolically, but they need that concrete to understand what exactly is happening symbolically, or they might need a visual to understand. So when you've done a problem with the class and you've exposed them to all these different ways of thinking about algebra, you now are probably going to take a representation from each category and connect those. So we added 3 here. We added 3 algebra tiles here. Where do we see that in the visual representation? Where does that show up down here in the symbolic representation? Where is this +3 are we seeing in all 3 of these different representations? And that's going to make those connections for the students, which is then going to develop that conceptual understanding. So to do that, we have a few tools that are useful, and this is a slide that we want you to interact with. So you should see 5 check marks. There are 5 different things here. We have the algebra tiles on the left. The whole left side is all about algebra tiles. Then we have on the right bar models, balance scales, the Desmos graphing calculator, and a double number line. Can you just drag a check mark over any of these that you're already really familiar with and you feel really comfortable with? And if you don't feel really comfortable with it, don't drag a check mark over top of them. Just leave the check marks on the side. And if you want to see what most people are thinking, you can come back to the Google Meet where I'm projecting my screen and you can see where people's check marks are falling. Okay, so our goal today is to touch on each of these. We're hoping we have enough time. I'm thinking we might not, but it's looking like a lot more of you are familiar with algebra tiles than I had anticipated, so that's good news. And then a lot of you are really familiar with the balance scale idea, so that's great news too. We are going to be spending quite a bit of time on the double number line and just touching on bar models. So good. Thank you for taking the time to help us be responsive to your needs there. Okay, so when we think about algebra, many teachers think the purpose of algebra is to solve for X. I'm really just giving them equations and I want them to figure out what can the only possible value be for X in order for students to be good at algebra. That's actually not the case at all. What you're doing is developing their algebraic reasoning. And what comes with algebraic reasoning is this big idea of equality and equivalence. And we sometimes lose sight of that in the just plain computation of 3x plus 1 equals 7. What is x? And if they get x, we think we've done our job. But do students really understand? And I'm going to just quickly go through these. That equality is an expression of balance. For many students, that equal sign means the answer is, and then they move on. They maybe don't understand that the two sides of an equation describe the exact same quantity. So by using these models and representations, that's going to develop that sense. Equivalence. Algebraic expressions can appear different, yet be equivalent objects. We are very quick in intermediate to get them to simplify an expression to its like simplest form. And not that that's a horrible thing, but it doesn't need to be the emphasis, okay? It is okay for them to see an expression looking very differently. So when you think about them moving into grade 10, they need to look at an expression in its vertex form. They need to look at an expression in its standard form. They need to look at an expression in its y equals mx plus b form. And each of those forms gives them a different piece of information about that relationship. And all of those forms mean the exact same thing, but look significantly different. So it's okay for us in grade 7 and 8 to actually get them looking at different expressions that are equivalent and getting them to prove that these different expressions are equivalent. The next point, equivalent algebraic expressions can be used interchangeably. So back to my previous example there. I might at some point want to use the vertex form. You don't have to worry about what that means. They get taught that later. But you're developing that understanding right now that I could use that expression in place of this one, and it will give me the exact same information. An algebraic expression can be treated as an object, not only as a procedure. I love this one. So we oftentimes, let's think about if you were going to go for a formula for perimeter. So 2 times length, but plus 2 times width. That's an expression. And we use that expression to get an answer for perimeter. So that's using that expression as a procedure. But many times in algebra, the answer might just be 3x plus 1. Like the answer might be the algebraic expression. So an algebraic expression is actually a mathematical object. It's not always a means to an answer. The next one, an equation can represent many different situations. So thinking about an equation, it could mean this is a cell phone plan, or it could mean this is how much it's going to cost you to ride a cab. So equations can represent many different contextual situations. And then the last one, often more than one equation or one set of related equations can describe a situation algebraically. So that's basically the same thing we've said all the way through, that oftentimes equations can look different but mean the exact same thing. So thinking about if you gave your students something where it had an expression on one side equaling another expression on the other side, like those are two equivalent expressions, and that's an equation that might represent something totally different over here, but be the exact same answer. So that is what you're teaching when you're teaching algebraic reasoning. You're not just teaching them how to solve for X. Okay, so here we go. You should be able to click on that classroom slide deck. This might be new to many of you. We're going to use the double number line to show equivalence. And I don't want you to worry about writing anything down, because the next slide that you can't see right now is going to have everything that I'm asking you to do written out for you. Plus, during summer school, we had Mariko Yoshi, Cameron G, and Amanda Berry created an actual slide deck for what we're doing for students. So a reference slide deck for students, and that is all going to be provided to you. So if you can click on that classroom slide deck link, and I'm just going to get myself set up here, so it might take me a moment. Okay. Now, we did this in our last session, but if you weren't here, ignore the very first slide. Slide number 2 is the master slide. That's there if you need to make a copy and give yourself some more lines. Find a slide that nobody else is using and put your name on it. And we're going to do some practicing, and you're going to notice that on the left of your slide are a couple arcs. There's a big green arc and then a little gray arc. You can copy and paste those, and that's going to make more sense in a moment when I explain to you what we're doing. So the idea behind algebra strings, it came from Kathy Fosno, who is the creator of the mini lesson book. So you probably in 7 and 8 have the green mini lessons for fractions, decimals, and operations with fractions, decimals, and percent book. So she came up with these algebra strings, and she based it on this short story that Mark Twain had created called The Celebrated Jumping Frog of Calaveras County. And so the first slide is just a couple pictures of that. So there's this actual competition that happens in Calaveras County. It's a big to do. They even have like a little princess of the jumping frog competition, and they've got a world record. Our Rosie the Riveter jumped 21 feet and 5 3/4 inches, which is ridiculous to think that a frog can even do that. But we're going to use this context to help students gain an understanding of equivalence when we're doing algebra strings. So the first thing I'm going to have you do, this would be phase 1. So this would be the first day that you're doing an algebra talk with your students. I want you to take that big curve, so the green one, the big arc, and this is going to represent one jump. And we're going to call it X. So you're going to put that at the top of one number line, probably the very top number line. So if this is one jump, I want you to show me, what does 3 jumps look like? So it would be on the same number line. Okay, and now you've all nailed it. It looks awesome. If I was in class with you, I might ask you, what would we call that? If we call one jump X, what would we call 3 jumps? And so now we're developing this understanding of a variable. So we would say that this is 3J, right? Or 3X, sorry. That this would represent 3X, what we have written right here. And the thing is the way the judges measure is how many steps a jump is. So for different frogs, a jump is going to be a different length, which is why this is a variable, because we don't know what frog we're talking about and we don't know how far they've jumped. So right now, we're just saying, we just know they did 3 jumps, but we don't know how far that is. Okay, so then my next question, so this is called 3J, what you have right there. On the same line, because you already have 3 jumps there, How about 3 jumps and 4 steps? So that little arc now is your steps. So what would 3 jumps and 4 steps look like? And if you have it finished, can you just insert a text box there and just write what would be the algebraic expression for what you've represented right now? So we know the jumps were 3x. Okay, I was hoping somebody would write what I've seen here. Fibonacci wrote exactly what I was hoping somebody would write. So Fibonacci has written that the expression you would see right now, oh, and so has Matthew, as 3x plus 4y. And I can totally understand why you would think that. However, we're going to make those steps our unit of measurement. So if that was my unit, then I wouldn't actually put a variable beside it. So we want to label this 3x plus 4. And the reason we're doing that is because we're going to measure the jumps in terms of steps. So how many steps is one jump? So what we can see here, what you've done right now on this number line, is you've shown me the distance for one frog that's gone 3 jumps and 4 steps. So everybody's got it. 3x plus 4 is the expression that you're seeing right there. So a couple of things that you would address with your students, and again, this is written on the next slide. The jumps have to be a consistent distance. Because this is one frog we're talking about, the jumps are going to be consistent. So this helps us understand about a variable, that the variable might actually be different for different frogs, but it's going to have an exact amount for one frog because it's going to be a certain number of steps. And the line is not partitioned, so the jumps and steps need to be illustrated very carefully, which is why I've given you these arcs. If you have mini whiteboards, students could just be drawing this themselves, but you want to emphasize that the jumps and the steps should be the jump should be the same size, steps should be the same size. Okay, next one. So that would be one algebra talk. One day you would just develop this so you could ask them, let me see what 4 jumps and 3 steps would be. Let me see what 4 jumps and 1 step back would be. You would just give them a bunch of things like that. That's phase 1. When you're ready to move past that phase, I want you to show me on the next number line 4 jumps and 3 steps. So show me 4 jumps and 3 steps on the next number line. Oh, Grace is so smart. Grace just copied the whole number line and pasted it over top of the other one. She said, I'm not redoing all these 3 jumps.
What was the question, sorry?
The question was 4 jumps and 3 steps. And again, if you weren't here for our last meeting, you might want to come back to the Google Meet so you can see my screen. I can see if this is like a vertical non-permanent surface virtually. I can see what everybody is working on right now because I have it in grid view. So I'm able to see what all the students are doing, and I can decide which students I would like to talk or which students I need to address later. So at this point, I would ask the students, what would be the algebraic expression for that? And because we're going a little bit accelerated here, I'm going to assume that you know that would be 4x plus 3. But I would take times with students to make sure that they understand that, and I would actually write the algebraic expression up there. So we have 4x plus 3. Now I'm going to ask you, if one jump is worth 8 steps, how far in total did this frog jump? So I'm going to repeat that. If one jump is worth 8 steps, how far in total did this frog jump? And I want you to try and show that to me on the number line that you're working with right now.
Rhonda, can you repeat the question? If one jump,
If one jump is worth 8 steps, how far in total did the frog jump?
thank you.
Okay, so we've got a couple things that I'm going to interrupt you that I want you to see. And I would like you all to start by going to number 4, the house of number 4, slide number 4. Now, can you see how this student has taken the steps and put them on the bottom of the number line? So this is how we show equivalency. We wouldn't put them on the top of the number line because that's the left side of the equation, okay? We want to show this is the equivalent to this many steps. So that number line is going to show the equivalency of steps. And you can see this student has shown us 8, 8, 8, 8, and then now would be doing like another 3 steps to connect with the 3 steps that the frog has taken. Okay, that is the idea behind it. Now, you might have some students who are going to do something similar to slide number 7. If you want to go to slide number 7. So slide number 7, the student said like, yeah, forget that. I'm not drawing all those little steps. I'm just going to write that I get each jump is worth 8 steps. Okay, that's fine too. Some students might need to visually do it right out so that they can see the distance. Some students might be fine with this. Either way is okay, as long as they can tell me that the total number of steps is 35, right? 8 times 4 is 32, 33, 34, 35. So this frog has traveled a distance of 35. Nobody, I was hoping somebody would do something wrong for me, but I couldn't see one anywhere. I was hoping somebody would take the 8 steps and put it on the top underneath each of those jumps. And that's what we don't want because we're trying to show equivalency. So basically what you are teaching here is substitution. You're teaching the students, I'm substituting the number 8 for the variable x, and I want to know the value of this expression by thinking about it as the distance of frogs. So that's phase 2. You might stay on this for a couple days, having students just do some substitution work. And this would be your number talk in the morning. So you might do 2 or 3 of these and then move on to your lesson for the day. Okay, a couple things to keep in mind here. Equivalence down the line. So remember when we were looking at slide number 4 and we were like, they're going to have to find the equivalence of those last 3 steps. So they're understanding that it's going to go 8 steps for each jump and then an extra 3 steps. So that's called equivalence down the line. Okay, here's your next number line. You ready? Here's phase 3. Once you're done practicing substitution for a few days, you move into solving equations. So here's an example of solving an equation. I want you to show 4 jumps and 3 steps is the same as 27 steps. So show me, and maybe Michelle, if you don't mind just typing that in the chat, show me 4 jumps and 3 steps is the same as 27 steps. So while you're setting this up, basically what you've given them is 4x plus 3 equals 27. Okay, and in them showing you that these 2 things are equivalent, they're going to figure out what x has to be if 4x plus 3 equals 27. It's a flock of geese. Okay, I'm going to interrupt you. I'm not happy that I have to interrupt you because I would love you to be able to play with this. But really, what we're trying to condense in 1 hour could be, an entire afternoon for sure, if not a full day of algebra learning. I would like everybody, if they could, to go to slide number 7. And I'm going to ask, I think it's Grace. If Grace, can you explain the first thing you did? Because I was watching you and I was really interested in what you did at the very beginning. If you don't mind unmiking and explaining to us what you did.
I think I have the mic off at this point.
I can hear you.
So what I did to start with is I added 3 jumps back from this, or 3 steps back from the very beginning, and then I was left with the jumps, but I had the rest of 24. So I just kept playing around with trying to figure out how many jumps would go for, or how many steps would be per jump with the 24 that I had left. But I started at this end and then I worked back and then just figured out what I had remaining to be split up.
You start at the right end.
Yeah.
Yeah. So this is what I saw Grace do right away. And I think I saw Chad do it as well. And I might have missed somebody else. It looks like Fibonacci maybe did it as well. This is called separating off. So students are taking those 27 steps and going, okay, it has to go the exact same distance as the top of the number line. So I know 3 of my 27 steps are going to match up with 3 of those steps on top. So they're separating that off. And when you think about how you would solve this algebraically, you would start by subtracting 3 from each side. You would separate that 3 off. So we've gotten rid of those 3. And now what Grace is saying is I'm left with 24 steps. So now I just need to figure out how to evenly split them up over four jumps. And that's going to tell me that each jump is actually a distance of 6 steps. So you would be connecting that for students. This is what we're talking about by connecting that symbolic and visual representation. So the first day that you just play with solving equations, you're just going to let them play with it in this phase and not worry about the symbolic piece so much. But eventually you're going to start connecting that to the piece. So if I'm subtracting 3, I've subtracted 3 from both sides. I've taken those 3 steps away, and you're going to show them that symbolically by writing 4x plus 3 subtract 3 equals 27 subtract 3. So we're maintaining the equivalence. So that's a really, really important piece, is their ability to separate off. Now, we did have one more that I wanted to do with you. However, that's an expression equaling an expression, so having a variable on both sides. I do want to touch on the other models, so I'm going to leave it for you to practice. And you do need to practice this quite a bit on your own before you start doing it in front of students. So we're going to leave this idea for a moment and come back to the pear deck. And there's a couple notes about this model. The having to redraw and the struggle is good. It's actually a really good thing in their conceptual development. So they're going to complain, and that's why whiteboards are so great, because they can erase and then they can redo and they can erase and they can redo, and they're going to be totally frustrated with you, and that's awesome. You're doing your job really well if they're super frustrated with you. It's making them think algebraically every time they have to erase. So the length of X changes depending on the question, and expressions are seen as objects that can be different but equivalent. This is the reference slide that I was telling you about. So we will be posting this slide deck in the long range plans, so you'll have access to it there. And if you click on that algebra strings link up here, which I will do for you right now, it comes to this absolutely beautiful slide deck that's been created, and this was created for students to be able to reference moving forward. So once you've done this with students a couple times, you can somehow put this in your Google Classroom or wherever you're storing stuff for students. Okay, what do you think, Michelle? Listen to it?
I think so.
Okay, so we're going to listen. This is Catherine Fosno. So she's the one who developed these algebra strings, and she's the one who's done those mini lessons. And the reason we're taking time to listen this is often I've heard from intermediate math teachers, oh, I don't bother with the number line. They don't use it in secondary. Boo to you. Big bad boo to you. The number lines is the one model that has the greatest legs in all of elementary and secondary. They're using it down in primary, so students are super familiar with it when you're using it, and they use it in secondary all the time whenever we have a coordinate system in front of them. The coordinate system is a huge number line that goes vertically and horizontally. So we want to continue to expose students to number line, and we want to hear from the expert on why that is. So if you want to come back to the Google Meet, I'm going to play this for you and you'll be able to watch. It's about 3 minutes.
This number line model is also powerful when you start thinking about it as a double number line and exploring equivalence, because you can write one expression on the top of the number line and one expression on the bottom and explore whether they're equivalent or not. This is going to become a powerful model, in fact, also for the development of algebra. Imagine a frog from Mark Twain's Calaveras County frog jumping. And imagine what referees do in frog jumping, by the way, is that they measure the length of the frog's jump, which really encompasses several jumps and some little steps. They mark it and they measure it in a unit called the frog step. So here's a frog that has done 4 jumps. And we will agree, if we're the referee, we're going to agree to assume that all the jumps are actually the same distance apart, because that's what the referee does in the jumping contest. This frog has gone 4 jumps in 8 steps, and he's landed at 52. So 4j plus 8 equals 52. My question is, how far will 2 jumps in 4 steps be? Now, if we're products of traditional schooling, most of us want to solve for j first. This means we have to say to ourselves, whatever you do to one side, you have to do to the other side. So we better start by subtracting 8 to both sides of this equation. Oh my goodness. All right, we've got a lot of steps. We get the solution for j, and then we plug it in, and we can figure out 2j plus 4. But you know what? If we treat 4j plus 8 and we think about it on the number line, we can almost imagine that 2j plus 4, twice is going to get us to the same place, right? So we already know that if 4j plus 8 is 52, then 2j plus 4 is half the way. Right? This is treating an algebraic expression as an object and really deeply understanding equivalence and how we can substitute and exchange. Now, this becomes really critical as we get to algebra. This is a common misconception in the literature that researchers have found that kids make this mistake all the time. It was found that children were asked to find an equivalent expression to 3x plus 36. And the large majority of people wrote x equals 12. And that's because there's no equation here. You can't even solve for x, right? And it's calling for an equivalent expression. So the correct answer would be 3 times x plus 12. That would be an equivalent expression, 2 objects that are interchangeable. But children are so used to hitting an equation where they're asked to solve for x that even when they see an expression, they immediately go to trying to solve for x. And they think to themselves, 3 times 12 equals 36. That's not at all what it says here. This is really critical because this development of being able to treat an algebraic expression as an object and substitute and exchange and actually look at relationships on a double number line.
Thank you, Kathy. Okay, so that just kind of reiterated what we've been hoping you've been collecting. So we want to just do a temperature check here. You should see a blue dot on your slide. Drag it to the one that makes the most sense for how you're feeling right now. And you can be honest because we have no idea who's dragging what to what. Okay. So it looks like most people get it, and there's a couple people who are a little bit confused, and in between, I understand, and a little bit confused. And that's good. We were kind of anticipating, it's not good, but we were anticipating that. So we're going to address that closer to the end of this presentation. We do want to take a little bit of time now, just in a little bit of time. We're only going to do one question because most of you said that you understood algebraic, how to use algebra tiles. So if you click on this classroom slide deck, we're going to do the same thing, and I have the question listed there. So we just want you to look at this. Where is it now? That's not it. Here we go. So you should be in a classroom slide deck called Algebra Tiles. So again, don't use slide number 2. That's the master one. But use anything from 3 on up. Put your name on it. And how would you show this equation and solve it using algebra tiles? And you can just drag those algebra tiles down. I've copied, all I've done there is I copy and pasted like 30 blue rectangles, 30 squares. So you're just dragging and just place them on top of each other. I was, what you could actually paste in here, Michelle, you were talking about this earlier, is you could put a pan balance in here.
Yes.
And just have students drag it. And if you're struggling with this, go look at what somebody else is doing on a slide. This is the point of vertical non-permanent surfaces, so that you can see what other students are doing and help you understand. So if you're like, I don't have a clue how to even go about starting this, go take a little walk around, do a little gallery walk. I don't think we need to be writing terms like bully on other people's slides, though. That's not appropriate. We're going to have a digital citizenship chat now. And get lost is not an appropriate term either. Seriously, eh, Michelle? How do we end up with this class? Okay, so once you've got it represented, which I see most of you do, so you weren't lying about being very comfortable with algebra tiles, I want you to solve it. So how would you go about solving this? And as you're solving it, think about how you would connect it to an algebra string or how you would connect it to the symbolic representation. Because it's not just about using algebra tiles, it's about connecting all these different representations. I see some of you lazy bums didn't even bother to put your name on the slide. Whatever. Dock you some points there. Thank you, Sarah, for fixing that. Sarah took some descriptive quality feedback and she used it for her slide, and she has improved her slide because of it. So has Scott. Well done. And Laura is definitely making use of some 0 pairs over there on slide 11. So this is why we started with integers, right? We wanted to have this understanding of 0 pairs because a lot of you are using 0 pairs right now, and that's important. And we also started with integers because, as you can see by those curriculum expectations, you are embedding integers now all the way throughout the year. Okay, if everybody can come over to SJ on number 12 here. SJ's done a great job of leaving the tiles on so we can see where the thinking was. So SJ, do you want to maybe just quickly explain to us where your thinking was there? Because it looks like you've managed to solve for X.
Okay, what I did was I made 0 pairs because I knew that a balanced equation. So I wanted to, if I'm going to do it to the right side, I want it to go to the left side, and I want to keep my excess positive. So I moved all of my positives from the right side over to the left side, but I'm subtracting them. So I made 0 pairs. Does that make sense?
Absolutely.
Okay, and then I needed to, quote, get rid of the -2 on the left side. So I made those 0 pairs, and then to keep it to keep the balanced equation correct, I had to move them over to the other side.
Excellent. So there's just a couple things I'm going to add, SJ. As you're talking to your students, we want to avoid saying move over to this side or move over to that side. But exactly what you've done here, you're saying like I added 2 positives to the left side, so I'm adding 2 positives to the right side because I need to keep that equality, right? That equivalence. So when we talk about moving over, they lose sight of the equivalence. But if we talk about it in terms of equivalence, that's the point that we want to get at. Right. So you did excellent.
Sorry. The other thing that I do with my kids is I pretend that I'm a balance, and that if I subtract something from one side, I actually go up on one side, so the other side goes down. What do I need to do to the other side to make it balanced? So I actually make it look like I'm a balance.
Yeah, that's an awesome, like giving them that visual of this is how we want to keep this. Yeah, excellent. Thank you so much, SJ, for sharing. And it looks like, it doesn't really look like, from what I can see at a glance, it looks like most of you grasped how to go about doing this. So I feel comfortable moving past that. So back to the pair deck. Just a couple points about that though. In grade 7 and 8, we don't use the big squares of algebra tiles. Those are x squared because they have dimensions of x by x, and that's a quadratic, and we don't get into quadratics in elementary. So that would be something with a degree 2. We only do degree 1, which is linear relationships. When you're looking at the tiles, X has a width of 1 and a length of X, and X is supposed to be unknown. So we don't really know. So this is how you introduce it to them. It's an area. We don't really know how long X is. Now, here's the problem with using a concrete manipulative for an abstract idea, because your students are going to look at the unit scores and go, yeah, it fits 5. It's got a length of 5. And yeah, realistically it does, but we have to think abstractly about this. So you're going to want to build some time in when students start to play with these algebra tiles, because that will be a major misconception for them. They'll be like, X is always 5, and you have to address it. There's no easy way of addressing it. Okay, this slide here, I think we're out of time, aren't we? Okay, we don't have to go into this. This is a Desmos version of algebra strings, and it's using the bar models. So if you're not familiar with Desmos, it's got a graphing calculator, which is amazing when we want to start graphing some of these linear relationships, but it also has another side to it, which is called teacher.desmos.com, which is full of activities that teachers have created and put on there. And if you're not familiar with that part of Desmos, please reach out to Michelle or myself, because we can walk you through a little tutorial and show you like all the great things Desmos can do. It's an awesome tool. So this is one created by David Petro, who is Canadian. He lives in Ontario. He's down by Sarnia, I think, Chatham or Sarnia.
Yeah, or Windsor.
What is it?
I think he's in Windsor.
Oh, Windsor. Okay. And it's the same idea, and it creates a great visual for students. He's also created these, which are paper models of those bar models. So if you're a distance learning teacher for cohort D and mailing stuff out, this is an awesome activity for your students to be working on. That is a paper version of everything we've just talked about. And then the very bottom one is like a creator. So it's just one that you can play with. It's not a set of activities. It's one you could just go on there and plug in different equations and expressions and have students like as a whole class lesson kind of thing. This reverse flow chart is the symbolic. We were taught, some people were taught, you know, oh, the number walks across the bridge, and when it gets to the other side, we're going to flip its sign, like whatever that is. I don't know what that is. That is not developing algebraic reasoning, though. So this photo actually comes straight out of the curriculum document, and it is called the reverse flow chart. So on the top, it would be, what would I be doing to variable m? For this expression that you see up here in the words. So we got m divided by 4 minus 2.1 equals 10.4. So we would take m, we would divide it by 4, we would subtract 2.1, and that would give us 10.4. So let's do that in reverse. We would take 10.4, we would add 2.1, we would multiply it by 4, and that's going to give us 50. So this is the symbolic representation, and it's including decimals here. But when you first do this, you're going to do this with integers, and you're going to connect it back to the concrete manipulatives and to the double number line. So you can say, like, why am I adding 2 here, 2.1? You would do it with 2. Oh, because I needed to add 2 positive algebra tiles so that the left side was left with only a variable. And then I had to do that same thing to the right side. Okay, so you want to be connecting all of these things. You can go right into the curriculum document. They have a big explanation about this under teacher supports that you can read on your own time. We provided this for you last time. This comes right out of our Leaps and Bounds resource that all grade 7 and 8 schools have. And it's just a quick explanation. If you're noticing that some students are really struggling with algebra, it might be one or more of these following points. So it's worth your time to read through these so that you're already anticipating before you go into the classroom. And you can start to notice these things and go, oh, I get why they're doing this. Okay, this is a super quick strategy harvest. These are some things that we've done today. We're just making it explicit because we're trying to also model for you how you would be working with your students. So we did a quick check-in Kahoot to make sure that you had good vocabulary. We used interactive Pear Deck. I don't know if you noticed the visual cues, but that is huge for students with executive functioning issues. If you just have an extra visual cue for them so they know, oh, this is going to be on a Google slide. Oh, there's a link. Oh, this is a video. We used Google Slides as vertical non-permanent surfaces. There was a Desmos interactive activity. We did a mid-lesson temperature check, which is always good to do with your students. And we've used visual models to build conceptual understanding. And we are right now going to do a quick exit ticket. So you saw this slide earlier in the presentation. If you can drag those question marks to any of these models that you're like, still don't quite get it, and be fully honest. So are there up there that you're like, yeah, I still don't fully understand? And I maybe wouldn't mind an extra little tutorial on that, because if we get enough people saying they don't understand something, we will make sure that we build in. And that's fair about the bar models because we didn't actually go into using them. So that's fair. Algebra tiles, very good. Okay, so here's what I'm going to suggest based on what I can see here. Bar models, lots of you are confused about. Fair enough, we didn't go in and try them. I'm going to suggest you go try them. So go into that Desmos activity. I will post this slide deck right after this session, so it will be in the long range plans. If you're still confused about bar models, please, please, please send me an email, Rhonda Hewer, and then I'll make sure that I create a tutorial for that. A few of you are still confused about algebra tiles. We need you to reach out to us because we'll create something where we can just sit down and play with those a little bit. Okay. A reminder, the algebra topic, the videos are up now for top 10 things to know in less than 3 minutes, except just between you and me, these ones go a little bit over 3 minutes. Lots of useful information in there that I did not talk about necessarily in this session. So worth your 3 minutes of time to go check those out. Those are right on the long range plans topic page. And we are not doing a just-in-time PD for the next topic because there's nothing new there. So grade 7, you're going into pyramids and prisms. Grade 8, you're going into angles and Pythagorean theorem. The only new thing there is that grade 8, you actually can go into Pythagorean theorem. In our past curriculum, we were only doing Pythagorean relationship. Now we're actually going right into Pythagorean theorem. So we are actually not doing a just-in-time because it's also 2 different topics. So our next just-in-time is going to be about fractions. operations with fractions. It's Tuesday, November 10th at 4 p.m. We will send you out a reminder for that. There always is going to be a Slido where you can post any questions, or you can go in and check out the Slido and vote on other people's questions so that we can see what the most popular ones are. And there was no questions in this week's.
Actually, Rhonda, there are two questions. There are 2 questions, and it's okay because they're easy. One is, what additional resources would you recommend? And I think that there are lots within that slide deck. So whoever asked that question, it was before 4 o'clock. I believe there are lots of resources to access within your slide deck. The second one.
Also on the long range plans, like those little learning through problem solving, purposeful practice, can all have problems in there as well.
Thank you. And the second question, does anyone know when MathUp will be available, if at all, for those who do not have it already? The answer to that is that you need to check with your administrator, your school administrator. For the distance learning teachers, I know that it is already in process, and we do not know when that process will be finished. But for brick and mortar schools, you need to check with your principal because there are no centrally provided license available. That is all the questions, Rhonda.
Awesome. And that, listen, folks, that was a whirlwind. That was like taking a full professional learning day and condensing it into 1 hour and almost 10 minutes. So if you're overwhelmed, I would imagine that you should feel overwhelmed. Please reach out to us, or just take some time to digest it and play with it a little bit. We thank you so much for coming. And I will make sure the recording of this and this slide deck gets posted. I think that's it.
Okay. I will stop recording.
Oh, Scott Morgan was Gauss.